Welcome to the webinar, Next Phase Floating Wind. I appreciate everyone joining us today. We have a fantastic panel lined up to give us all the inside track on the latest developments in floating wind power. This webinar has been created in conjunction with the Offshore and Floating Wind Europe 2019 conference, which is being held in London this November on the 11th and 12th. So today we've got a fantastic panel with Eric and Paul from Quest Floating Wind Energy and Henrik from Hexagon. Paul will be kicking things off with a look at the global market outlook, helping us to identify the hottest markets, biggest players, and the roadmap forward. Henrik will then take us through Hexagon's floating design, exploring technical challenges that we're all racing to solve as we move closer to commercial scale. And then Eric will follow on with the Quest's QVision platform to show us some real-time data. So we will then be taking a short, a good-sized question and answer session. We're going to leave plenty of time for that, so please do send your questions in throughout all the presentations. We'll get to them at the end, and we will try and answer as many as possible. So yeah, great, send them in. So Paul, I'd like to invite you to share your screen now, if you can, and kick off the presentations.
Very good. Thank you, Dominic. We appreciate you, you and New Energy Update organizing this fantastic webinar. We're very pleased to participate. Just for confirmation, do you see my presentation?
Yep, we're all good.
Thank you. Well, let's get started. Good morning, good afternoon, good evening, everyone, depending on where you are. We're happy to be here today. My name is Paul Hillegeist. Just a bit about us. We have expert knowledge of the energy value chain from 20 years of experience as Quest Offshore, where we engage clients with our strategic insight. We actively develop strategic relationships with management teams of prospective clients, current clients, of course, operator developers, leading designers, tier 1 and tier 2 supply chain, etc., and across the global financial sector. We are focused on the full market for offshore wind, and we provide various products and subscription services as well as a full consultancy. We have evolved, really focused on offshore wind, evolving from Quest DNA, which was 20 years of experience in predictive analytics and technical market expertise, where we focused on energy, specifically upstream oil and gas. Now we're dedicated to renewables. And the honeycombs shown here, it really are our core capabilities. So on to the presentation. We'll provide a macro overview, and we'll get into the offshore wind market with a comprehensive overview of fixed and floating, and then take a deep dive into floating wind. And finally, we'll end up with our LCOE modeling exercise. It's exciting to see that renewable energy is the fastest growing energy source, accounting for 40% of the increase in primary energy usage, leading to a highly diversified energy mix beyond 2040. New investment in renewable energy over the next decade is a multi-trillion-dollar enterprise, intent to deliver a growing share of total electricity demand generation. Renewables led by wind, offshore wind, and solar are growing exponentially and delivering bigger capacities at reduced cost. The global energy transition to a lower carbon footprint presents many opportunities across industries to tackle new challenges through innovation and applied technology. Growth in the offshore wind market is projected to outpace onshore wind by more than twofold, and it's highly favorable for our industry that costs for offshore wind have plummeted more than 50% since 2012. In September, Quest debuted its Quest Offshore Wind Index, which illustrates a burgeoning offshore wind market totaling 11,087 wind turbines, representing 96.8 gigawatts. The index comprises the competitive landscape of global fixed and floating offshore wind projects in various stages including under development, planned, and possible. Our index shows $248 billion in Capex for a universe of 145 fixed projects and $47.6 billion in Capex for 52 floating projects, representing a total turbine count of 9,117 and 1,570 turbines, respectively. The uniqueness of CODI, Quest Offshore Wind Turbine Index, illustrates vital industry metrics on offshore wind economics for developers in the supply chain, including LCOE and Capex per megawatt. The index also includes a monthly tabulation of leading industry indicators as weighted averages, shown here highlighted in orange, such as rotor diameter, which has leaped to 172.4 meters, megawatts per unit, now 8.7, distance to shore, nearly 38 kilometers and growing, and notably water depths, average 103 meters, 30 meters for fixed and 459 meters for floating. The monthly index also summarizes pertinent segments of the global supply chain, displayed in light blue and red, including Capex and other key metrics across 6 segments for cabling, substructures, turbines, moorings, anchors, and installation. In its entirety, the index contains 28 key data attributes for 24 countries, organized into 4 regions and comprises 2,520 total values. Ahead of delving into all of our market statistics, just a brief note of reference to explain our methodology. In the absence of valid confirmed total Capex figures, of which there are few, we employ our proprietary QVision cost model, which is a bottom-up summation of project cost. Quest applies 18 base-level cost variables to the particulars of each project to derive 15 cost subsegments, which are then parsed into our 6 top-level Capex segments mentioned earlier. And you see them illustrated throughout these pie charts. Again, substructure, turbine, cabling, installation, mooring, for floating only, and other, which includes project management, construction, insurance, contingency, etc. Please also note that any variations in these upcoming figures as compared with our Quest Offshore Wind Turbine Monthly Index would reflect current project updates, as our index is published the first week of the month. QFWE has conducted primary research focused on comparisons between fixed and floating offshore wind, as illustrated in this output. Note highlighted on the left, fixed units demonstrate an average Capex per unit of 25.6 million US dollars compared with an average Capex per unit of 33.1 million for floating, shown on the right, and an average Capex per megawatt of 3.3 million and 5.4 million, respectively. In short, we predict new age floating projects will be highly cost efficient, and further, we fully expect to see meaningful trends that demonstrate movement towards cost parity with fixed over time. This will become acutely clear once multiple contracts are placed for large-sized projects, each comprising between 50 and 100 units or more, where serial manufacturing can and will be applied. We will highlight these economies of scale at the end when we share a sampling of our LCOE modeling with you. As shown on the left, the total addressable market in Capex for fixed turbine units totals over $266 billion. And with respect to supply chain segmentation, the turbine spend shown in green is projected at $120 billion, a 45% share, followed by substructure Capex, the 24% share, about $65 billion, highlighted in dark blue. Cabling spend of $31 billion, 12% depicted in yellow, and in red, installation Capex totaling $24 billion, representing a 9% share of the total. For floating turbine units, as shown on the right, the total addressable market in Capex totals about $49 billion. By segment, turbine Capex totals over $19 billion. Substructure spend 22% or $10.5 billion. Mooring Capex in gray of $6.9 billion, 14% of the total. And cabling spend of $6.4 billion and installation spend of $1.4 billion. Now on to our full regional analysis of the future offshore wind market by sector. When combining fixed and floating projects, Europe, no surprise, is the top market, representing more than half of total megawatts, nearly 53 gigawatts, and a total addressable market in Capex exceeding 157 billion. In fact, over the past decade, Britain's offshore wind capacity alone has grown 20-fold and now represents about 25% of their renewable generation. Moving to other regions, again representing fixed and floating in combination, Asia Pacific totals over 28 gigawatts, a 27% share totaling 95 billion in Capex, while North America totals 22,400 megawatts, or 20% slice, and a Capex spend of nearly 70 billion. For bottom fixed units shown on the left, the European market represents a 53% share, 142 billion of spend, followed by Asia Pacific with 27%, and the Americas at 52 billion. As shown right for floating, Asia Pacific represents a 45% share of floating turbine unit spend, followed by the Americas with a 39% share, 19 billion, and Europe with a 16% share, 7.6 billion. Now for a closer look at fixed offshore wind activity by project in Northern Europe. This Power BI tree chart depicts fixed offshore wind activity by project size as measured in Capex. As shown on the far left, the first two columns of colored blocks represent the largest projects in the region, which cumulatively represent about 56 billion, or 36% of the spend. Similarly, the middle two columns depict 14 projects totaling 40 billion, or 25% of total spend. The UK continues to demonstrate its dominance of bottom fixed wind on the heels of Equinor's recent announcement to develop 3 large-scale offshore wind projects in the Dogger Bank region of the UK North Sea. Once online, the Dogger Bank wind farm will be the world's largest offshore wind farm development, with a total installed capacity of 3.6 gigawatts. This eclipses Hornsea Project 1 and 2, and this record will likely be broken once more when Ørsted's Hornsea Project 3 is commissioned post-2025. Back to Dogger Bank, which will comprise 3 distinct projects, utilizing 10-megawatt wind turbine generators secured to monopile foundations. A game changer for Equinor's offshore wind business, the Dogger Bank auction results are testament to continued cost reductions, accelerated technology development, and reflect the vastly improved overall economics compared to the industry's early days. We'll shed direct light on this momentarily when we debut examples of our LCOE modeling efforts with you. Major players like Ørsted currently dominate offshore wind, representing 1/3 of the market outside China, and look to continue their growth trajectory in pursuit of a 2025 goal to achieve more than 9 gigawatts of offshore wind capacity, which is more than double their current power. All the while, established onshore wind developers such as EDF Renewables, ENGIE, EDPR, and Iberdrola are looking to expand their opportunities offshore. As an example, over the next 6 years, Iberdrola is expected to grow their offshore wind capacity by a factor of 8, albeit from a small base of about 350 megawatts. As shown center, early purveyors of floating wind designs, and those gaining the most traction presently, include SWIVEL Offshore Technologies' Tetraspar demonstrator for the Shell Energy co-developed project off Karmøy, Norway. And other collaborations include EDP and Repsol's investment in Principal Power's wind float design Gen 1 and 2, being deployed on demonstrator and pre-commercial floating wind projects off Scotland, the French Mediterranean, and Portugal's Atlantic. And you'll hear specifics about Hexacon's innovative design directly from Henrik shortly. Notably, our industry is witnessing the accelerated entrance of new players from deepwater oil and gas, such as Equinor, Shell, and Total. In addition, a growing number of supply chain participants that are legacy oil and gas. Active in wind include Aker with PPI, Doris Renewables, Saipem, Seaway 7, Hirama, Prysmian, Nexans Oceaneering, and JDR TF Cable, to name a few. Note that list includes notable engineering firms such as KBR, Wood, and Gusto MSC, now an NOV subsidiary. Now a deep dive into current floating wind, shown here, activity amongst these 12 designers, isolating on those projects in the under development stage, which reveals a total addressable market in Capex of nearly $2 billion, comprising 51 floating turbine units, FTUs, across 15 projects, which represent $554 million in substructure Capex, another $641 million for turbines, $290 million of export inter-array cabling, and $56 million for installation activities. Asia Pacific is a definite bright spot. Shown here is floating project Capex by developer. Quest sees the near domination of floating wind presently shining through across the Asia Pacific, denoting 787 FTUs, floating turbine units, or nearly a 50% share of the global floating total of 1,609 FTUs, and representing a total addressable market exceeding $22 billion in Capex. According to QVision, Quest's proprietary business analytics tool, this slide reveals that Iolfi, Acacia, and Marubeni will drive 65% of the region's spend, with projected Capex of $14.5 billion, representing $3.2 billion and $1.4 billion, respectively, for substructures and cabling, plus another $2.5 billion for moorings and $461 million plus for installation activities. Of note in the region, Sweden's Hexicon has partnered Shell in South Korea for the 200 megawatt Dounreay Twin Wind project in the Sea of Japan. Hopefully, Henrik will tell us more. Another giant leap for floating. October's Quest Offshore Wind Turbine Index will see a surge of European floating units, buoyed from the UK's recently announced floating to hydrogen wind plan, floating wind to hydrogen plan, which denotes an ambitious 4 gigawatts of floating wind in the North Sea beyond 2030. As shown, a deep dive on turbines associated with floating projects in the under development stage sees 627 million Capex for the turbine addressable market, representing about 32% of total spend. The portrayal of rankings by turbine manufacturers shown in the pie reveals a leading 34% market share for Siemens Gamesa, followed closely by MHI Vestas with 30% and GE with nearly 16%. As you may have gleaned in our earlier statistics, specifically the segmentation spend for turbines shown in green, now that 10 megawatts and 12 megawatt turbines are garnering deeper market penetration as the preferred choice of developers, the percentage of total turbine spend is growing in relation to overall Capex as their nameplate capacities are increased, along with the expanded footprint of turbine blades and associated components. This slide illustrates floating offshore wind activity by project size, with a view towards the variable project mix relative to project size across the globe. This Power BI tree chart illustrates floating offshore wind activity by project size as measured in Capex. Excuse me. As shown on the far left, the first two columns of colored blocks represent the largest projects, which cumulatively represent about $27 billion in Capex, or 55% of total spend. These are the ones you want to chase. Finally, to wrap up with our LCOE modeling. Now on to high-level results as illustrated from our LCOE modeling in the following scatterplot charts from Power BI for 160 fixed and 43 floating wind projects, which demonstrate modeled values to allow comparisons between projects already built and those planned in the future. As shown, when comparing the levelized cost of energy between fixed and floating wind projects by online year, it's clear to see that costs are falling rapidly, both in fixed and floating. Apart from some outliers, we clearly recognize this trend. In bottom fixed projects, the red dots, Beatrice, which came online in 2018, was recorded at some $170 per megawatt hour, while the recently announced Dunkirk project something like 4 years out, settles at $65.50, nearly $100 lower. In floating, shown in the blue dots, we see two projects highlighted in Europe and South Korea, Windfloat Atlantic in Portugal and Dounreay Twin Wind, which both fall below the trend line at $114 and $118 respectively. As a benchmark, in 2019, Europe's average LCOE is $69 per megawatt hour US dollars, which is less than half the cost as compared to 2012. And finally, another illustration. When comparing the levelized cost of energy between fixed and floating wind projects by project size, shown here, you can see the steady progression towards lower costs for each, in addition to the cost benefits from economies of scale over time related to larger sized projects. Also shown are the relationships between pre-commercial and commercial projects as the ones we've highlighted. This chart is more fragmented than the previous chart because it shows the LCOEs clearly by number of units. In fixed, we see increasing project size, not necessarily resulting in lower cost. As an example, East Anglia 1 is 50% larger than East Anglia 1 North, but almost twice as expensive, at least in our modeled cost. Economies of scale are easier to identify in floating wind. The cost reduction between the Yolfi, pre-commercial, and Britannia, and the projected 20-unit, 12-megawatt follow-up Britannia Sud project looks to see a decline well over 60%, perhaps more. We fully expect that once 100 to 200 unit projects become the norm, hopefully sooner rather than later, that their costs will come in well under $100 per megawatt hour. QVision. Finally, QVision is our robust analytics and market analysis platform available by subscription and the foundation for all the statistics we've just shown you. Please call us for more details and for a demonstration. And finally, we offer a full consulting advisory service. Thank you for your attention and interest.
Thanks for that, Paul. Very insightful, a lot of data there, a lot of things to digest. Had a lot of questions coming in right now, but like I said at the start, keep bringing them in, and we'll go through them all at the end, and you'll have obviously Eric to help you as well with that. So now we'll be moving on to Henrik. Henrik, I've just requested that you share your screen if you want to jump onto that, and we can get going.
Very good. Thank you very much, Dominic. Thank you also for organizing this webinar. Also, I'd like to pay my respects to Quest for bringing metrics into the rapidly expanding and evolving offshore wind market and floating wind market, because I also have an experience from oil and gas, and that metrics is invaluable when you try to grow your business. So thank you very much for making that effort into floating wind as well. What I'd like to do, my name is Henrik Borszewski. I'm the CEO of Hexicon AB, based in Stockholm, Sweden. One of the countries that has a lack of offshore wind of any significance. However, a long tradition as a shipbuilding nation many years ago, and actually the first oil production asset that was floating was built in Sweden, and some of the engineering was later bought by KBR, but there's an heritage for construction and design of floating assets, and from that we have brought some talent together, and we tried to enable some further efficiency to the floating wind market. We are not an early mover. We have been following the different demonstrators in operation both in Europe and Japan and US. And what I will go through with you in a few pictures is a few slides, is the components, the standard components that enables to have two turbines side by side in all weather conditions. So first of all, a little bit about the concept. A floating unit, what we design is the yellow and red and the mooring system. It's all based on standard turbine components, and all the design criteria is set by the standard criteria from the wind turbine manufacturers. The design as such is turbine agnostic. However, there is of course a very important design phase to integrate turbine, mooring and floater into one product. It's a semi-submersible platform. What that means is that you use water ballast to bring stability to the unit. So when we have a construction without ballast, it has a draft of approximately 5 meters, and then you tow it to site with conventional tugboats. With both towers and turbines raised and tested in a protected environment. And then you connect to pre-laid cables and mooring systems in a wind park. The ballast draft is approximately 15 meters. So you have thousands of tons of water ballast to have the semi-submersible to behave pretty much like an island. And when I was a lot younger, my first ride with a helicopter to a semi-submersible floating oil drilling rig in the Gulf of Mexico, you would step out of the helicopter and think that everything will be moving like a vessel. But to everyone's astonishment, it's lying still, even though the waves are big. And this is the benefit of having an open steel structure where the power of the wave just passes through the structure. The ability to weather vane with the unit is the single point mooring system, where all anchor lines are vertically coming out of a turret in the third corner of the triangle. And this is also well proven in the oil and gas industry. And I will show you here just an animation of the functionality as such. This is very new to the wind industry. Neither onshore or bottom fixed, you can actually move the position of the turbine as such. You only have the yaw of the nacelle. But with our enablers, we actually move the floater with the wind direction. And what is now the benefit? Well, there are several benefits that will take me hours to give you a detail about. Just email me if you want more than the summary I give today. But one of the main benefits could be shown here, how you can add additional turbines to a given water area. With 2 turbines on each platform, you have a lot more capacity available with the same wake loss. So all these animations are done with using proven software simulating what the capacity increase can be. The water area of 25 square kilometers in the North Sea that we have a permit for, we can put 70% more capacity into that water area with having less units, but 2 turbines of each. The key component, 2 components to enable this is number 1, that the mooring system is a single point mooring system, and there's a large turret designed which is fixed to the mooring system, and bearings allow the hull, bearing the 2 floating turbines to actually weather vane. Just like you're anchoring your motorboat or a tanker offshore, it will always turn into the wind direction. The other component that is a key for the ability to turn is the electrical swivel, where the transfer of both optical cable and electricity through from the turbines into the able to export it to the sea bottom and bring the electricity ashore. The swivel as such is already in manufacturing and used in other industries, standard components as well. Without these two components, we could not have a twin turbine concept. Here's a little bit more details about the drawing of the swivel and the turret. I could also point out that the designers that have experience of designing turrets in the oil and gas industry view our turret as being the most simple design of any turret, because it only carries the mooring system and the cable, whereas in oil and gas you have risers and pipes and God knows what coming through a system. The dynamic cable doesn't really bring any added value from a twin turbine concept. It's the same kind of dynamic cable that is used by any other floating device for wind power. The main benefit is that we need one cable for two turbines and not one cable per turbine. So we have half as many dynamic cables in any given wind park. And whether it's if you have 100 turbines, we need 50 cables instead of 100. And that is probably the most expensive part of the cabling cost within the floating wind park cost structure. So we save on Capex. Fabrication. The illustration you see on the right side is the dry dock in the city of Ulsan in South Korea. It's one of the larger in the world. And the two yellow triangles is the relative size of our triangles. And to be able to serial manufacture in a protected environment, we estimate will bring the cost down per unit larger within floating wind hulls than in the bottom fixed industry. And the simple reason is that whether the water depth is 50 meters, 100 meters, or 150 meters, you actually manufacture on exactly the same drawings the whole wind park. This is not the case with either monopiles or jackets. So serial manufacturing is the key enabler for cost reduction, and the cost reduction curve, I estimate, is going to be steeper than we have seen in the bottom fixed market over the last 10 years. Our first generation project had the vertical towers and columns, and that was all our data was design criteria was based on the North Sea harsh environment. We still have the permit, which is about 8 kilometers off the north coast of Catenary in Scotland. Dounreay is an old decommissioned nuclear power plant, and the grid is well renovated for renewable energy transportation. The mooring system in the Dounreay case was specifically made for that project to be a CATENARY mooring with chains with a clump weight about 20 meters above sea bottom, and a fairly large footprint, but with 6 anchors only for 2 turbines. The engineering procedure went pretty far. We had all the pre-feed, feed, and detailed design done. We both wind tunnel testing of a model of 1 scale to 225, and also a 1 to 50 scale wave and wind tank testing exercise performed to verify all the computer simulations. It's about 100,000 engineering hours spent. And with that, we have then tried to optimize the structure. And then we come to what we call the generation 2, where we are actually tilting the columns and towers to reduce the size of the triangle, to which will make a hull structure of less weight. Also, we have a hybrid mooring system under development, which is one would say a hybrid between TLP. We have tension in the mooring lines and a much smaller footprint on the sea bottom, and you would then combine that with floating turbines on the two back corners. And this is not, I think, applicable for all waters around the world, but for several water areas, this mooring system could be quite efficient. The savings in metrics, I just want to highlight in this table the platform weight. And you can see the shadow is the generation 1, whereas the yellow and red is the existing design that we are developing for the first wind farm in South Korea. It's a smaller triangle carrying, in this illustration, 5 megawatt turbines. We bring the the platform weight down from over 6,000 tons to just over 2,500 tons, with the same weather characteristics, which is harsh environment North Sea. The idea of having 2 turbines side by side, we have done quite a lot of R&D around, together with Uppsala University north of Stockholm. That is probably the #1 Swedish faculty for wind power aerodynamics. And we have in their supercomputer made some very interesting tests, bringing the turbines closer and closer to each other to try to see how close can they be without any increase in loads or fatigue or losses in production. And you can see the tables on the right where the actual results are fairly similar to a single standalone turbine. So the ability to have 2 turbine motions side by side without interference is actually better than initially thought. And if we look at, there are some, of course, will be some misalignment issues when waves and wind are not in sync certain time periods, but it's a very conservative numbers, small numbers when it comes to energy loss because of misalignments. This picture is just to show that we're not alone thinking about multi-turbine rotors. This tower was published December 18 from Vestas, a test unit onshore in Denmark, where they stated that there was a power gain of approximately 1.5% due to the interaction between the rotors with a multi-rotor wind tower with 4 rotors. So this is still early days to see what the gains perhaps may be, but at least in our simulations, which is not in prototype like the Vestas machine here, there is no energy loss anyway in our simulations. We're pretty much in the midst now of computing and moving forward with the design criteria in the wind park in South Korea. And so far we have not run aground on any showstoppers. To the contrary, it's actually enabled by conventional mooring systems as well, even though the triangle is somewhat smaller. The Every project needs to have its own input when it comes to before design, which is of course both water depth, tidal range, wave, wind, soil bottom conditions, and supply chain infrastructure. And here I would say that probably there's no better country to commercialize large scale of floating wind than in South Korea. The large shipyard capacity is well beyond any other nation. Maybe at least that's the experience in oil and gas. Now maybe China would claim that they are even larger in shipbuilding capacity than Korea, but it's really been a big benefit. It will be a big benefit for serial manufacturing in South Korea for that home market. As I said, there are both our own mooring system with TLP element, but the catenary mooring system, there are pros and cons of both, and it'll be the project that decides which one will be the chosen one for any given wind park. Our IP is pretty much described in these two pictures, where we have a tilted tower and turbine, so two such as one unit. That patent is granted in Sweden, and we're now in the PCT process. And the same with the mooring system, is not granted yet, but applied and protected. We do also have an in-house software to compare single turbine wind parks with twin turbine, to be able to quantify the capacity increase and the cable reduction decrease, which are two main benefits of twin turbine concepts. That software is verified by third parties, made with industry standards, and we will be able to use that for any feasibility studies on the planet. There is some interesting intelligence also in the code, so we're experimenting with maybe having a more asymmetrical wind farm layout to gain production. So with this, I'd like to thank you all for listening, and look forward to the Q&A.
Excellent, thank you, Henrik. That was great. Great to hear. I'm now going to invite Eric, just with a little consciousness of time, because we want to get to the Q&A. So keep questions coming in. We've had loads of questions and we won't get to them all, but that's not to say don't send them in, because I have made a note of all of them, and I'll be sending them out to Henrik and Paul and Eric as well after the webinar, and hopefully we'll get something sent out to you next week with all the slides and all the questions answered. Okay, so on to Eric. Here we go.
Good day, everybody. Thank you for joining. Indeed, given the time needed for Q&A, I will try to get through this with turbo speed, if you don't mind. We've been looking at the presentation from Paul. This is to show you where all that data comes from. We have a QVision suite of data packages, which is fed by a rather comprehensive database on projects, which per project fills about 250 data points that our team is tracking on a daily basis. So you will see that any data that we show is being updated on a 24/7 basis. The main screen is a screen that will show you all the projects around the world. It shows a number of filters already where you can choose whether you will see something on a regional level or maybe drill deeper. I will show for that the other page where all the filters are shown, which are the project names, the designers, developer names. Obviously, the main filter is whether you'd like to see the fixed data or the floating data. And here, not only on regional level, you can also drill down on national level. So you will be able to see which projects are currently under development in France or any other country for that matter. You can also select on segmentation, and that will go throughout the module. And sorry for my email messages, but this is online, so this is actually streaming data. The next page will show you the Capex overview based on LCOE. Paul has shown this already. The good thing about this is that we can slide here and select certain values. We can again go into the regional level, and I'd like to start by clicking floating here, and that will mean that throughout this procedure, throughout all the sheets, we will see floating data only. This is really a comprehensive tool. What is more important, it is really fun to work with because we know all the data is there. The purpose may differ per person. If you're in sales or if you're in research or an analyst, each of us will have a different look on data or a different need for data, and obviously the abilities to filter and move the data around gives you a great insight in exactly the kind of data that you're looking for. The analyst will maybe look for the statistical data and may have some streaming problem here. So I'll try to do this by voice. The analyst may be looking for statistical data. The salespeople or business development people may want to look more for the opportunity in the market. We have a segmentation called to be decided, which is one of the most interesting fields in the whole package, because obviously that is where you can see what is still to be decided for. Indeed, that's where the opportunities are. We have in this sheet that Paul also showed, we have a comprehensive overview of the market both on the fixed and the floating side. We can look at all the details per segmentation throughout the software package. We can look at a certain time window and see what happens to the Capex per megawatt or the Capex per unit for that matter. The sheets will give you all the filters that you need and all the segments that you need to know. We have a whole list of filters, both on LCOE, Capex by developer, by segmentation. So it would surprise me if you find anything or miss anything in there. The quality of the data is reliable because our model decides for us what the outcome is. We are sometimes surprised ourselves by the outcome of some of the analysis we do, and our data architect David Sutherland and I, who spend hours and hours on trying to find some of the relationships between the data, sometimes have great fun in trying to double the cost for a certain segment like cabling to see what happens to the Capex or the segmentation cost. And indeed, if you would experience that, you will see for yourself what the possibilities of the data are. I think I'm going to try and close this so that we have time for the Q&A session. I thank you for your attention, and I look forward to the Q&A session after this.
Excellent. Thanks, Eric. Okay, so let's just dive straight into some of these questions then. So got a question here for, I think everybody can answer these, but this one first came through for Paul. So speaking for the US market, would it be possible for accelerated deployment of US offshore wind to impact the trajectory of construction costs to drop by 10% per year?
Can you,
Yep.
Dominic, can you hear me?
Yes.
Good, thank you. Thank you for your question. I believe it wasn't cited whether it was specific to fixed or floating, so they're different. But the near-term projects, of course, Vineyard Wind is undergoing another federal level environmental review, so that there's some maybe politics involved. But we're seeing progress on those projects, and you're talking is 10% a year total cost reductions feasible? I would say they are. We can certainly run modeling on that, giving more parameters and specifics. The floating projects for the Pacific are a little bit further out, but they're starting to gain traction relative to the state of California's environmental goals, including carbon-free goals moving as early as 2045. But those projects, the ones we're looking at, I believe Eric can speak more specifically, are at least 50 units or more each. They're 500 megawatts or a gigawatt or more type projects that are 4 or 5 projects that are being in the plan stage. So those would absolutely be serial manufacturing.
Okay, great. So, we have another question. The total floating wind market projections, $49 billion US, 12 gigawatts by 2031, represents projects that have reached FID, or is that in development?
That's thank you for the question. It's the full universe of projects that are not online. So it would start with those projects currently under development for installation this year or beyond, installation and commissioning. And we have another planned status and a possible status. The possibles are not, there's some variation between the statuses, and we have an FID data attribute, but most of the possible projects do not have FID.
Okay, got a question here for Henrik. How advanced is the swivel connection for the electrical cable as the floater is turning around a single point?
I would say that the design will be finalized during 2020, but it's all based on well-proven standard components when it comes to the electrical swivel. And the dynamic cable also is fairly new to the wind industry, but there's many years experience of dynamic cables in the oil and gas industry.
Okay, what is the Henrik again? What is the level of redundancy on the single point mooring in relation to cables and in relation to load bearing?
That's a good question. Depends on where you are, but you have in the dimensioning of the mooring system is of course a very critical part of the whole design work, and that can only be frozen once you decide on the turbine size. And in the Korean case, of course, it's a fairly moderate weather conditions compared to the North Sea. However, there's a typhoon element, so you have much more severe loads rather than fatigue issues, and those can be accommodated. Of course, there are other more floating assets in the Asian Pacific than floating wind parks, but the mooring systems have to be rigid enough and have the redundancy accounted for. And here we are working very closely with the classification societies.
Excellent. So can the just thinking about O&M here, can the platform yaw be locked to allow access?
The turbine depends on the size of the project, I would say. You could do sort of deviations from the standard turbines if you have a large enough commercial order for the turbine vendor. So it's pretty much a part of the interaction between the turbine manufacturer and the floating in the design team. Yes, you can lock the yaw, and we do actually restrict the yaw with the tilted towers. You cannot yaw 360 degrees. You can only yaw outwards.
Question for Quest guys. Where do you collect the Capex data? Someone's questioning the project specific, and surely they're therefore confidential.
This is Eric. We have a wealth of sources, but generally what we do is find the most, let's say, public data in screening the sources, both online and in person. We talk to developers and designers. Obviously, the Capex is not something that is being easily shared. So what we do normally is run our cost model, come to a certain conclusion about Capex, and then try to verify with the developer or the designer, and then they are generally prepared to indicate where we are. And we know the system works because we're running our own verification methods where we see that our accuracy is well within small margins.
So Eric, is the data more likely to overestimate or underestimate the market size? Is this the same for fixed and for floating?
I'm sorry, I missed the first part of the question.
So is the data likely to overestimate or underestimate the market size?
Typically what you see is that, especially longer out, new projects are being announced, other projects disappear. In the beginning, let's say 4 or 5 years ago, there were a lot of speculative projects announced, most of which or a good chunk of them have disappeared. We learn by our own verification methodology how reliable a certain developer obviously is by statistics, but also we have about 16 criteria by which we measure a project, so that when the project goes forward, let's say that one of the milestones, a big milestone, is, for example, is there a PPA, is there an FID, is there a consent? That is the easy part. Much earlier on, it's a lot more difficult, and we verify or have a project qualify on the quality of the technology, the financial stability of a company involved, and so on. So it's like I said, it's about 16 criteria that make the puzzle complete.
Thanks, Eric. This is Paul. Excuse me. Just one comment to that. Long term, it's underestimated because it's not a full forecast. This is a bottoms-up approach to identified and known or announced or to be announced projects. So long term, it's not we're not looking at creating projects that aren't there. We do that in kind of on the consulting side, but because this is a bottoms up, we have tangible pieces of information on that they're looking at developing either from a designer side or from the developer side. This is the early stages in the cases of the possible projects, early stages of putting together plans for a project.
Okay, so just to jump back to Hexagon and to Henrik, we have a question here of what turbine supplier would you plan to use, and what has the OEM feedback been in regards to tilted towers?
The turbine supplier will be announced when it's all finalized and agreed to announce it, but it will be a well-known Standard Turbines. This project in South Korea is an effort to what shall I say, fairly catch up with going for a large commercial wind farm straight away. And we don't need to experiment on turbines. We will focus very much on the behavior of the foundation and optimizing for low LCOE on the wind farm operation, construction operation. Also, it's worthwhile to maybe mention, to Eric's point on the market signals. 2 years ago, I think that the sizing of market potential in Korea was quite different than today. The actual political decision last year to have a feed-in tariff for an electricity remuneration that increases the further offshore you are, that's unique. And that decision was made last summer in Korea. And it only took about 6 months for 4 or 5 international developers to establish a relation with the city of Ulsan. And from that, the water is sold out. There's no more room for any additional developers in that area. So it just tells you how quickly this industry can grow if we have the right decisions made. And there could be countries out there that we don't know about today that will come with a decision, and within months there's going to be strong competition about gaining water acreage and grid access for having a profitable wind farm operation.
Okay, I believe we've just about run out of time. So in the interest of not getting cut off by the software, if we already haven't, we'll be able to answer all your questions. I will be sending the questions out to our panelists, and we'll try and get these wrapped up to you. I will deliver them with the presentations and the full recording sometime sort of early next week. Obviously, we're going to give the guys a couple of days to answer these questions. There's been a lot of interest in this webinar. So lastly, I'd just like to thank our 3 panelists, Paul, Henrik and Eric. Fantastic presentations, fantastic Q&A. I'd like to remind everyone that this was produced in conjunction with the Offshore and Floating Wind Europe 2019 conference, which is being held in London. If you're